Allylic alcohols, as we have done in allylic in case of haloalkanes and haloarenes, it is same thing. Okay, very similar. Allylic will have the double bond on adjacent carbon. A for allylic, A for adjacent carbon. Good way to remember. So if you have the functional group on this carbon, the double bond will be on adjacent carbon. This adjacent carbon will have the double bond. Okay. Functional group is on this carbon, adjacent carbon to this carbon will have the double bond. Why allylic alcohols? Because alcohol is the functional group here. OH is the functional group. In case of haloalkanes, haloarenes, this was say chlorine, bromine, etc. Otherwise, it is same thing. Same primary, secondary, tertiary, same concept. This one is tertiary because here in this case, the functional group is attached to the carbon, which is attached to three carbons. So the carbon is tertiary here. This carbon is 3 degree. You will consider always that carbon which is attached to functional group, no other carbon. So here the carbon which is attached to functional group is secondary carbon, 2 degree carbon. Why it is 2 degree carbon? Because it is attached to two carbons. This carbon which is attached to functional group is 1 degree carbon because it is attached to only one carbon. That's why primary, secondary, and tertiary. Benzylic alcohols. So benzyl group, benzyl group is not benzene. Benzylic group is when you have a CH2 attached to it. So this is benzylic group, not this one. Here, these hydrogens can be replaced by other alkyl groups also. That will also be called as benzylic group. That will actually represent secondary or tertiary. So if one hydrogen here is replaced by alkyl group, it becomes secondary. Why it becomes secondary? Because the carbon which is attached to functional group is attached to only one carbon, sorry, two carbons, one and two. So that's why it is 2 degree carbon. Here, this carbon which was attached to functional group was attached to only one carbon. So that's why it was 1 degree. Here, the carbon which is attached to functional group is attached to three carbons. So that's why 3 degree tertiary. Now here we have some compounds, their common names and their IUPAC names. Common names are equally important in many cases because in questions you actually get common names. You might not get the question on common name itself, that what is the common name. So this is highly unlikely question, highly unlikely. But in the question text itself, you can get common names, and if you don't remember the common names, you will not be able to solve the question. So from that perspective, common names are important. Methyl alcohol, because hydrogen is replaced by, in methane, hydrogen is replaced by OH. So methyl group, alcohol. Propyl group, alcohol. Okay. And because there is no branching, N-propyl alcohol. This one is isopropyl alcohol. Why? Because you can write it, rearrange it as CH3, CHOH, CH3. This branch CH3, CH3, you have written like this. And this is iso group. There are three carbons, propyl, isopropyl. OH is there, isopropyl alcohol, because iso group is there. Here you have N-butyl, the N-butyl alcohol, but this one is sec-butyl because the carbon on which functional group is attached is a secondary carbon. That's why sec-butyl. Now this one, again you have iso group here, but total carbons 4. Iso group with 4 carbons, isobutyl, OH, alcohol. All common names you have to remember. Divya, good evening. Now the next one. This one is the alkyl group attached to alcohol, and this group is a tert butyl. This is 3 degree carbon. Compare it with this one. The carbon which was attached to OH group was 2 degree. So that's why sec butyl, secondary butyl. Here the carbon attached to alcohol group is 3 degree, and there are total 4 carbons. So 3 degree with 4 carbons, tert butyl alcohol. This one has a specific common name, glycerol. You need to remember. So in propane, when hydrogen of each carbon, one hydrogen from each carbon is replaced by alcoholic group, then it is known as glycerol. Propane 1,2,3 triol. IUPAC names are comparatively easier in all cases. Okay? But still, if you are not getting any IUPAC name, why it is so, just go through all and let me know, I'll explain. Remember, in this case, the longest chain is this one. Longest chain must have the functional group attached directly to it. Okay, unless it is impossible. So there will be few cases where there will be different type of functional groups. We will consider the maximum number of functional groups in the longest chain in that case. Now this one, who will tell me the IUPAC name of this one? And I am telling you, many wrong answers will be there. 2, 3 wrong answers will be there. What is the name of this compound? Write in the chat box. Preeta, yes, good. Ashi, yes, good. Mahak, yes. Divya, no. Everyone, you need to be active. Divya, see the structure again. Ahan, yes. Arohi, yes. If you don't answer, it means you don't know. Vangi, yes. If you are not telling me the answer, it will be considered as you don't know. Tuhina, yes. Armina, no. Shashwat, no. I said I will get 2, 3 wrong answers because you will consider it as benzene ring. It is not benzene ring. It is cyclohexanol. You don't need to mention one here, but if you mention, that is not wrong. Okay, if you say cyclohex one all or hexane one all, correct, but no need to mention cyclohexanol. Is correct. Tell me this one. What will be the name of this one? Quickly. I don't think it is that tough. You have done IUPAC naming. You just need to mention that it is OH there. That's what you have to consider only. Yes, Ashi, correct. Mehak, yes. Just no, Mehak. There is slight mistake. Ahan, slight mistake. Preeta, correct. Shashwat, yes. No, correct. Shashwat, yes. Shivangi, Yes. Anna. Yes. Mehak. Yes. Yes. So first of all, quite a few mistakes, and you did not include cyclo there. So you have to include cyclo if it is cyclic. Don't just say pentan. Arohi, Tuhina. Yes, correct. So you will say here 2-methyl cyclopentanol, pentanol or pentanol, correct. Because wherever all is connected, that will inherently be first position. So you don't need to mention one here. This is first position, this is second position. 2-methyl cyclopentanol. Now these ones, common name here, phenol, IUPAC name also phenol, because this is benzene ring. 2-methyl phenol, you know 2-methyl phenol because it is one, it will be two. Common name is orthocresol. Orthocresol. If OH is at meta position, or you can say CH3 is at meta position, it is 3-methyl phenol, 1, 2, 3, or metacresol. Meta positions are at alternate positions in the benzene ring. Alternate positions in benzene ring are called meta. Adjacent positions are called ortho. Opposite positions are called para. Opposite positions, that's like paracresol, and 1, 2, 3, 4, 4-methyl phenol. Here again, common names you need to remember. Otherwise, IUPAC names you can write very easily. Benzene 1,2 diol. If it is one, this will be two. If this is one, this will be two. Whatever one you choose, it will always be benzene 1,2 diol. The common name of it is catechol. At meta positions, but you will not say it is meta. For example, if one group is methyl, one is the alcoholic group, then it was cresol here. Okay? Methyl and alcohol OH group, then cresol. But if both are OH, you will not say ortho, meta, para. There are different specified names in that case. If they are on adjacent, catechol. If at meta position, then resorcinol, resorcinol, okay, or benzene 1,3-diol, 1, 2, 3. At opposite sides, then hydroquinone or quinol, benzene 1,4-diol. Common name, just write and memorize. Hydroquinone or quinol is same thing. Some more compounds, their common names and IUPAC names. Ether, related to ether. This is dimethyl ether. Ethers are those ones which are alkyl groups attached to oxygen. These alkyl groups can be same or different. If these are same, these are called symmetrical ethers. If these alkyl groups are different, unsymmetrical ethers. Symmetrical ethers have dimethyl ether or diethyl ether. Unsymmetrical will have both written separately. So it is methyl and N-propyl. So both you need to write methyl and N-propyl. It will be in alphabetical order. And then ether. Here you have this one is as phenyl. This one is methyl again in alphabetical order. Methyl, phenyl, ether. Or this is also called anisole because if you see this is OCH3. OCH3 group on benzene ring is known as anisole. Common name is anisole or methyl phenyl ether. Then you have phenyl group and ethyl group. Again in alphabetical order, ethyl, phenyl, ether. Or there is another name, okay, phenitol. Then here you have phenyl, and you have total 7 carbons in sequence. So it is written as either heptyl phenyl ether, or you can say N-heptyl also. It is written as N-heptyl phenyl ether or heptyl phenyl ether, same. If N is not mentioned, that is inherent. Yeah. Then here oxygen, this side you have methyl, and this side you have isopropyl. So methyl, isopropyl, ether. Then again here you have phenyl, but here you have isopentyl. This is iso group, but total 5 carbons. So that's why isopentyl. Now there are few compounds which will not have the common names, only IUPAC. Now if I consider IUPAC names will have the alkane main chain at the end. So main chain will be of the larger alkane. Main chain will be of larger alkane. If both are same, then any. So in this case, both are same. So it means it is methane. So you will say methoxy methane, ethoxy ethane. Okay. Now here the main chain will be the larger one. This one. So it means propane. So you can say methoxypropane, but methoxypropane can be like this also. CH3, CH, CH3, OCS. Means methoxy group can be at second position also of propane, the main chain. So that's why you have to mention it that where methoxy is connected. Methoxy is connected here at first carbon, 1, 2, 3. So that's why it will be one methoxy. So don't just say methoxypropane. Okay. Now here in this case, benzene will be the main chain. Ethoxy, ethoxybenzene. Main chain is benzene. Here the main chain will be of 7 carbons, not benzene of 6 carbons. So you will say one phenyl, sorry, phenoxy because O is there, one phenoxy heptane. Now this is something what I told you here, that here methoxy group is connected on the second carbon. So it is actually, if you see here, it is CH3, CH, CH3, OCH3 is attached here on second. So it is same thing. So 2-methoxypropane. This is the main chain, and second carbon you have methoxy. Now here you have one side as phenyl group, benzene group, and here you have isopentyl. Okay. Now isopentyl, when you say here, if you consider this as main chain, it will be very difficult to name it. Okay. Although another name is also written in quite a few books. I will tell you what that name is. Okay. So here we will consider this one as the ether group. Okay. And when we consider this carbon will be 1, this one will be 2, because it is attached to this main chain. So this carbon will be 1, which is attached. 1, 2, 3, 4. At 3, we have methyl group. So that's why it will be 3 methyl. And then in this chain, you have four carbons. These four carbons with this oxygen will form butoxy. And then we have benzene. So we will say 3-methyl butoxy benzene. However, in few guides, you might get it written as, okay, this one as phenoxy and this one as main chain. So here in main chain, you get three, sorry, uh, one phenoxy, 3-methyl, 3-methyl, one phenoxy butane. Understand why? This is considered as main chain, but because here it is connected at first carbon, something is connected. So this will be the first carbon, second, third, fourth. First carbon you have phenoxy, third carbon you have methyl, but methyl M comes before P. So that's why 3-methyl, 1-phenoxybutane. But this one is widely used. So you should use this one. Then the last two, these two do not have any common names, only IUPAC names. Okay. Now, why IUPAC names? Because here we have just this as root and two groups are attached. At if we don't consider these two groups, if we consider these two groups as hydrogens, then it will effectively be CH3, CH3. And in many cases, to understand what is the root chain, you will have to replace the substituent groups by hydrogen. This is a good way to find out what is the root chain. At a few places, it will help you. So if you replace these two by hydrogen, this is ethane. So that's why the root chain will be ethane. And these are methoxy groups at first and second position. That's why 1,2 dimethoxy ethane. This one again seems typical and quite a few wrong answers again because students consider this as benzene. This is not benzene. This is cyclohexane. Okay. Now, very important point because here we have two groups attached. It means this has to be one. Because if I write 1, 1, 2, and if I consider this one as 1, this will be as 2. It will be 1, 2, 2. This one is smaller. So I have to consider 1 this, 2 this. And then alphabetical order you need to arrange. It is ethoxy. These are methyl. E comes before, so that's why 2-ethoxy 1,1-dimethyl cyclohexane. Out of 70 marks, 5 marks will be there for just IUPAC names. It's a good chunk. Yashtika, yes, the numbering part is you choose the branching which gives you least number. You choose that branching which gives you least number. Suppose you consider this one as 1, then this will be 2. So in that case, it will be 1-ethoxy and 2, 2 dimethyl. It will be like this. At 1, you have just one branch. At 2, you have two branches. At 1, you have one branch. At 2, you have two branches. That's why you have written 2 times. Okay. But if you consider this one as 1, this one as 2, then at one position you have 2. So you will write 1 2 times. And at second, you have only 1. So you will write 2 only once. 112 is less than 122. So this is least or less in this case, you can say. This will be considered, not this one. Okay. Name the following compound according to IUPAC system. Tell me the name in chat box. Slightly tricky, but good question. Okay, yes, Ashi, correct. The best way to learn is that you try your best during the class. Be active. Um, mm, 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 no, Shivangi, no, Divya, no, Mehak, no, Preeta, no, Ahan, no, Shashwat, no, Vandana, yes. Arohi, you are close. The only thing is you have done the numbering wrong. Otherwise, you have got the idea. Okay. It will be 3-chloromethyl 2-isopropyl pentanol. If you remember, in the beginning, I said you will keep the alcoholic group, functional group in the main chain. Okay. Quite a few students have overlooked that. Okay. So main chain will actually be this one. And if this is the main chain, this carbon is one, this two, three, four, five. Means five carbons. Pentanol. At third carbon, you have chloromethyl. At second carbon, you have isopropyl. C comes first. So 3-chloromethyl. At second position, isopropyl. Five carbons, that's why pentan one. Okay. These type of questions slightly tougher than this one will be there. So understand all these questions. And if any concept is not clear, any point is not clear, don't hesitate to ask. Otherwise, it will be too late. Next, tell me the answer here. Divya, the previous one, if you're talking about here, because you see what I have drawn as main chain, the main chain will have OH. So main chain will have these carbons. How many carbons are there? Count: one, two, three, four, five. These are five. Is that clear? No. Now tell answer of this one. Okay, Ashi, correct. Just find the longest chain containing the functional groups. Mehak, correct. Just put Rita mention, you need to mention die there. One, yes, that is acceptable. I'll tell you where, slight mistakes are there, and many of you have done that mistake. And when I tell you, just pay attention to that one. Although I have said your answers are correct, but that slight mistake is still there in many cases. Uh, Arohi, okay, correct. Shivangi, yeah, Shivangi, your answer is completely correct, except one another mistake, not that one. Shashwat, no. Sudipta, you got the concept, but it is not hexo. Now, see, those who have given 2,5-dimethylhexane 1,3-diol, absolutely correct. A few students have not written this E. This E will be there because we have here D, diol. Okay. So many students have written 2,5-dimethylhexane 1,3-diol. Next, name the following compounds according to IUPAC system. And this one is easy. Tell me the answer. No, Ashi. One keyword is missing. Now correct. Mehak, correct. Arohi, correct. Shashwat, yes. Preeta, it is IUPAC name. Avoid mentioning meta. Do the numbering. Shivangi, yes. It is not. If it is not benzene, meta, para, ortho, do not have any significance here. So, Hina, uh, yes, correct. Ahan, cyclo keyword is missing. Ahan. 3-bromocyclohexanol. You don't need to mention one all because that will anyway be first position. Otherwise, bromo cannot be on three position, third position. If you mention that is absolutely fine, not a problem, but not necessary. Cyclo keyword was missing in many answers. Next, name the following compound IUPAC system. Yes, Ashi, correct answer. Preeta, there is double bond also. So mention the position of double bond. You have written it correctly, but you need to mention the position of double bond. Shashwat, no. Mehak mentioned the position of double bond. Arohi, correct. Shashwat, uh, mention the position of double bond. Preeta, yes. Tuhina, yes. Tuhina, yes, but still just one slight correction you need to do. I'll tell you what. Shashwat, yes, this is a way acceptable, but still one slight correction required. Shivangi, correct, but position of double bond is not correct, and that slight correction is required still. Now see here, the longest chain which has OH connected to it is this one. 1, 2, 3, 4, 6 electrons means hexane, but numbering will start from left side. 1, 2, 3, 4, 5, 6. At 3 you have all, at 1 you have double bond. Okay? Double bond is always on the previous carbon, remember, from where the numbering is propagating, means from left side or right side. So it is propagating from left side, double bond will be on the previous, that is first. Ahan, yes. Vanna, yes. Correct answer, Vanna. Dev, yes. So the answer will be hex 1 in 3 all. The correction which I said will be required. Many students have mentioned E here. E. E will not be there because otherwise two vowels will be in succession. Two vowels cannot be in succession. You will remove that E. And why it is hex only? Because there is double bond. In double bond, you need to separate the ene. So otherwise, it would have been hexene. Okay, hexene. This one is appearing here. That's why hex is here. So don't mention it as hexane 1 ene. That will be wrong. Hex 1 ene. Hexane to hexene. But mention the position of double bond as 1 here. So hex 1 ene. Don't just say hexene. Hex 1 ene, 3 all. At third carbon you have all. At first carbon you have double bond. Now answer this one. Shashwat, correct answer. She, yes, correct answer. Shivangi, correct answer. Mehak, correct answer. Preeta, yes. Arohi, yes. Tuhina, yes. Devya. Uh, Devya, there is double bond also. Sudipta, Sudipta mentioned the position of double bond. You can skip position of OH because that will be inherent, but position of double bond has to be mentioned. Yastika, it will be 2 in D will not be there. I think that is auto correction. Otherwise, your answer is correct. Yastika. Vanna, yes, your answer is correct. Ahan, yes, correct. So it will be 2 bromo, 3 methyl but 2 in 1 all. Now remember, in this case, You can write it as enol also, because if I am saying 2 bromo, okay, and 2 ene, it means this alcohol has to be at. It cannot be at any other place. If it is at any other place, that will change the sequence. But it is always advisable, as I said. In this case, it is advisable to mention 1 4. Okay. Now, a few students, in previous batch said, no, sir, it is possible that we can have OH here also. If we have OH here also, then also numbering will start from here, but OH will be on 2. It is not possible. It is not possible because carbon already has 4 bonds. It cannot have 5 bonds. So OH cannot be here. Okay, now structure of functional groups means the angle, if it is methyl alcohol, if it is phenol, okay, or if it is methoxymethane. These angles are sometimes asked, and if you are planning to appear in competitive examinations, important. And explanation is there. Here angle is 108.9 degree, here it is 109 degree, here it is 111.7 degree. And the reason is very simple, because here you have hydrogen. Hydrogen is very, very small atom. And here you have methyl group. So there is some angle 108.9. If instead of methyl group, you have slightly heavier group, which is benzene, okay, means the distance between these two will increase. So slightly the angle will also increase, because benzene is larger group. So it will go away from hydrogen. But in the third case, there is no hydrogen. Hydrogen is very small atom, but methyl groups are both larger. So now both are larger. These will occupy more space. So here it will be largest angle. Methoxymethane, largest angle. Now the preparation of alcohols. Preparation of alcohols from alkenes, from carbonyl compounds, from Grignard region. Mm, Arohi, okay. Yes, that is considered, but in all cases, you have two lone pairs and two bond pairs. In all cases, two lone pairs, two lone pairs, two lone pairs, and two bond pairs. So that's why the explanation on the basis of lone pair bond pair is not that much effective. The explanation is on the basis of the molecular mass, or how heavy the ligands are, these attachments are, on that basis. Yeah. And moreover, if you want to understand this one, that why this bond length is smaller, there is resonance. So due to resonance, this bond length is smaller due to partial double bond character. Otherwise, this is 142 and 141 picometer. With methyl group, it is very close. With hydrogen, it is 96 picometer, because hydrogen is very small atom. So oxygen and hydrogen, very small hydrogen. So that's why this bond length is small. But oxygen and carbon are larger groups, so that's why larger atoms. So that's why larger bond length between CO. Between oxygen and hydrogen, it will be very small bond length. Any confusion? Okay. Preparation methods, as usual, as we talked in case of haloalkanes and haloarenes, very important here also, very important. Preparation of alcohols. All these reactions will be used in conversion. First one is by acid catalyzed hydration mechanism and hydroboration oxidation. From alkenes by acid catalyzed hydration, this mechanism is also asked very frequently. Acid catalyzed hydration. So, in accordance with Markov-Nikov rule, when we get alkenes reacted with water, water is HOH, the negative part OH minus will get attached to that carbon which has less number of hydrogen atoms. Okay? So in this case, this carbon has less number of hydrogen atoms. These are two carbon atoms of the double bond. This carbon has less number of hydrogen atoms, so OH will get attached to this carbon as per Markov-Nikov rule. Okay. So it is not the Markov-Nikov rule. Markov-Nikov rule was given for haloalkanes. That's why it is written as in accordance with Markov-Nikov rule, similar to Markov-Nikov rule. Now, what is the mechanism here? The protonation of alkene to form carbocation by electrophilic attack of H3O plus, because water actually H2O exists as hydronium ion. Okay, this hydronium ion has positive charge on oxygen. So what happens? To neutralize this positive charge, this double bond breaks. Sorry, this bond breaks. When this bond breaks, this hydrogen gets detached as H plus. This gets detached as H plus. And this H plus gets attached to this carbon. There is heterolytic cleavage. So in heterolytic cleavage, what happens? That both the electrons will go on one carbon, say on this carbon. So when both the electrons will go on left carbon, the right carbon will gain positive charge. And now because it has two electrons, these two electrons will be given to this proton, and this proton will get attached to this carbon. So you get carbocation formed. Carbocation is formed this way. Then H2O molecule again attacks the positive center of the carbocation because H2O has three electrons, electron pair on oxygen. And this is addition. Water molecule gets added to carbocation. It gets added with oxygen. So this water molecule gets attached to carbocation. Now, because this carbon has less electron, that's why it has positive charge. And this oxygen gives both of its electrons to form the bond. So this bond is actually formed by both the electrons of oxygen. Oxygen has given its electrons. So that's why oxygen gains positive charge. Now, when there is positive charge on electronegative species, it is unstable. It is not very stable. Okay? Although because there was transfer of electrons required, it transferred its electrons and formed the addition product. Addition product means water molecule got attached. But being positive charge on electronegative species is not stable. So that's why deprotonation happens now. This hydrogen or this hydrogen This bond gives its electrons to oxygen. And now because this hydrogen doesn't have any electrons, it gets detached as H plus. And this oxygen gains the electrons. That's why now it has normal charge, no extra charge, positive or negative. This OH remains on the carbon, and this hydrogen which gets detached, okay, is attached to water molecule and again forms hydronium ion, which was at the beginning. To understand the steps, the three steps are protonation, nucleophilic addition. Nucleophilic attack here is actually nucleophilic addition. Then deprotonation. Protonation, nucleophilic addition, deprotonation. Write these three steps. This mechanism is very common. Okay? What is this mechanism known as? Acid catalyzed, because it happens in presence of acid. When we have very little amount of acid, then ionization increases and more hydronium ions are there. So availability of H plus increases, so more hydronium ions are there. So that's why the term acid catalyzed, and that is the key word you need to remember, acid catalyzed, related to this mechanism. Preparation method of alcohols from alkene. Acid catalyzed hydration. Hydration because it is reaction with water. Next is hydroboration oxidation. Slightly typical reaction. And in conversion reactions, you will omit these parts. You will just write it once, okay? And then you will write just this from here to here in conversions. Okay? But if it is asked as preparation method, okay, or in any other form, you will write all the steps. So what happens? You have alkene. Again, we are talking about preparation of alcohols from alkenes. So second method is hydroboration oxidation of alkenes. So we get it reacted with diborane. This is diborane, which is actually B2H6. B2H6 is actually exists as BH3, BH3. That's why diborane. The name is diborane. We have written it like this, HBH2. It is actually BH3 whole twice, but we have written it as HBH2 whole twice because we will say that hydrogen will go to one carbon and BH3 will go to another carbon. Now this is slightly specific reaction. Why? Because you might be asked that why hydrogen in this case goes to this carbon and BH2 goes to this carbon. The reason is, in this case, hydrogen boron bond, this bond, HBH2 bond. This boron is electropositive, more electropositive than hydrogen. So hydrogen actually has slightly negative charge, boron has slightly positive charge. So the negative part will go to the carbon which has less number of hydrogen atoms. So it is again in accordance with the Markovnikov addition, although not just Markovnikov addition, but in accordance with that. So hydrogen in this case will go to that carbon which has less number of hydrogen atom. And this is slightly different, so you need to remember that. After that, once this has been produced, it again reacts with alkene. Okay, it again reacts with same alkene which is present. Now consider this one as, this one you need to consider written as CH3, CH2. This is actually CH2, CH2. BH2. I write it like BHH. It means boron now has three arms. I have just rearranged this one. Okay. Boron has propyl group and two hydrogens attached. Okay. Now, when again it is reacted with this propene, then this group again one group is added. So one hydrogen is replaced. This hydrogen is say this hydrogen is replaced, and here another CH2, CH2, CH3 is attached. It means you have two groups of propyl and only one hydrogen. Then again it reacts with propene and the rest of the hydrogen, remaining hydrogen is again replaced. Now you have three groups, propyl groups, and no hydrogen. So now boron has all three as CH2, CH2, CH3. After that, we get it reacted with hydrogen peroxide, okay, and some hydroxyl group from some base in presence of water. Then we get alcohol. Reaction is slightly tricky, so try to write it 2, 3 times and memorize it. This question is asked as it is: right hydroboration reaction or right hydroboration oxidation, or how will you prepare alcohol, some alcohol from this particular alkene by reacting it with diborane. All cases, this is the answer. Write down the reaction and make sure that after the class you write it 2, 3 times. Hydroboration oxidation. So this is something same thing written, that the boron atom gets attached to the sp2 carbon atom carrying greater number of hydrogen atom, or you say hydrogen gets attached to that carbon which has less number of hydrogen. A better way is to understand how I explain that boron is slightly more electropositive than hydrogen. That's why hydrogen is slightly more electronegative as compared to boron, hence gets attached to carbon with less number of hydrogen atoms. The alcohol so formed looks as if it has been formed by the addition of water to the alkene in a way opposite to the Markov-Nikov's rule, okay, which is actually just looks like. Okay? And why it looks like? Because hydrogen in this case is electronegative, comparatively electronegative than boron. In this reaction, alcohol is obtained in excellent yield. That's why this reaction, hydroboration oxidation reaction, is preferred method for production of alcohols. Why? Because if you see three molecules or 3 moles of alcohol produced, so quickly the alkene is utilized there. Next one is from carbonyl compounds. Carbonyl compounds means having CO group. This one, carbon. First one is by reduction of aldehydes and ketones. Both aldehydes and ketones have CO group. Okay. RCOO OR dash or RCOH, ketone aldehyde, carbonyl group. Simple methods. And remember, this is reduction. So it is easier to remember. Reduction is done by palladium or reduction is done by lithium aluminum hydride in presence of sodium boron hydride. Write down these reactions, very important. In presence of aldehyde, palladium is preferred. In presence of ketone, lithium aluminum hydride is preferred. Lithium aluminum hydride does not require hydrogen. Palladium will require hydrogen. So make sure that you understand the difference here. Okay. When you use palladium, it will not provide any hydrogen. So you will have to use hydrogen. If you use lithium aluminum hydride, it will provide hydrogen from itself. Second one is by reduction of carboxylic acids and esters. These also have carbonyl group. CH3COOH, for example. So CH3C double bond OOH, carbonyl group. Esters CH3CH2COOCH3, for example. Again CH3CH2C double bond OOCH3, carbonyl group. Again, first you use lithium aluminum hydride. Once reaction starts, after that, after some time, you add water, not both at the same time. So whenever it is written as 1 and 2, it means one after the other, not at the same time. Again, it is reduction by lithium aluminum hydride. Lithium aluminum hydride is an expensive reagent, very expensive rather. So the reactions which have lithium aluminum hydride are normally not conducted in laboratory. You will not get lithium aluminum hydride in your lab. Okay. So lithium aluminum hydride is an expensive reagent and therefore used for preparing special chemicals only. Commercially, acids are reduced to alcohol by converting them to esters, followed by their reduction using hydrogen in presence of catalytic hydrogenation. Means palladium, platinum, nickel. Reduction using hydrogen means platinum, palladium, nickel with hydrogen. Although this reaction, yes, important, and you can write it, but in reality, lithium aluminum hydride is used only for special chemicals. Okay. So here, acid is converted to ester first by getting it reacted with alcohol. And this is very common reaction you will see. Alcohols reacted with acids will give you esters. Remember it. You will be using it in quite a few scenarios. To get ester, what you do? Acid and alcohol. One way I tell students if they are not able to memorize, one way I say that you have alcohol here, okay, and you know alcohol, wine, beer, whiskey, these are all alcohols, and you add vinegar into it. So you have wine here and you add vinegar into it. And what is vinegar? Vinegar is acetic acid. What is alcohol? Alcohol is say C2H5OH. So when you get vinegar reacted with wine, you get ester. So you can visualize it, okay, to remember. So if alcohol is there in a glass and you add vinegar, sorry, you will get ester. These esters can easily be reduced by hydrogen in presence of platinum, palladium, or nickel to alcohols. From Grignard agents. Grignard agent has very good applications in organic chemistry. Okay, so the mechanism. You have the carbonyl group here, and this is the Grignard agent. The specific feature or property of Grignard agent is that alkyl group is slightly electronegative, and the reason is similar to what I explained in case of uh, diborane. Okay, that hydrogen is slightly electronegative here. This is slightly electronegative because magnesium is highly electropositive. Because magnesium is highly electropositive, this alkyl group is slightly electronegative, and the carbonyl group, carbon is partial positive. This bond is polar bond, oxygen is electronegative, carbon is electropositive. So this electronegative attacks on electropositive carbon. So alkyl group gets attached to the carbon, and the remaining part of magnesium halide is connected to oxygen because this is positive part. This positive part gets connected to oxygen. After that, we add water. So when we add water, this MgX part is detached and we get OH, hydrogen, instead of MgX. The product, intermediate product, is called adduct. It is called adduct because the entire of Grignard reagent is attached to the carbonyl group. R part gets attached to carbon, MgX part gets attached to oxygen. So that's why we call it adduct, intermediate product. Two important steps you have to mention. And in reactions, you can skip this one. If this is conversion reaction, in conversions, you don't need to write this one. First step is reaction of carbonyl group with Grignard agent. And second is the adduct formed gets reacted with H2O. Yastika, adduct is the intermediate product which has been formed by addition of two compounds. So here these two compounds are actually added to each other and made one compound. These two combined and formed just one, got added to each other completely. No, Ashi, in that case, basically the reaction is in two steps. Those two steps are not required here, but that's why. It is not that they will react. So this is an example. The example is that you have CO group here as HCHO, and you have R, MgX. R will have slightly negative charge, Mg will have positive charge. Here it will be positive charge, and this oxygen will have negative charge. R will get attached here, and MgX will get attached on this oxygen. So what you will get? You will get HCOMgX, and here it will be HR. Yeah. Now this H was already there. Just understand it like this. R will be here. So this will form CH2. Okay. R got attached here. MgX got attached here. You got this product which is actually CH2. RCH2 OMGX. So I'm writing it like this, RCH2 OMGX. After that, we get it reacted with H2O, that is HOH. This MgX and OH will combine and O will get attached with H. So we will get R CH2OH plus MgOH. So if mechanism is asked, this is the way you will write. If reaction is asked, you can write directly without any arrows. Okay? And moreover, just make sure that your arrows are correct. For example, in case of oxygen, the arrow will be like this, from oxygen to magnesium. It will always be from negative to positive. Arrows movement will be from negative to positive. It is opposite to dipole moment. In dipole moment, it is positive to negative. But in mechanism, it is negative to positive.